We're going to start looking at factoring today, and we're going to begin with looking at what is the greatest common factor. So before we do that, just a quick definition of what a factor is. A factor is basically two things that are multiplied together. So if I give you just a number, if I give you the number 10, and I say, give me the factors of 10. Well, we would have 1 times 10, those are both factors of 10. And 2 times 5. Those are the only factors of 10. I could say, give me the factors of 3. Well, 3 is a pretty easy one because it's prime. The only way we can multiply to get 3 is 1 times 3. So the factors of 3 are just 1 and 3. Okay, so when we talk about the greatest common factor, it's really exactly what it sounds like. It is the biggest or the greatest number or the greatest factor that two numbers have in common. So if I said, what is the greatest common factor of 10 and 3? Well, if we look at their list of factors, there's only one that they have in common. So for those two, the greatest common factor would just be 1. There's not anything else that's common, and there's nothing bigger than that one that's common. Okay, so here we have 3 numbers, and it says find the greatest common factor of 15, 24, and 27. We're not going to do this for every single greatest common factor, but I am going to make a list of each of the list of factors for these numbers so that you can kind of see what we mean by the greatest common factor. So for 15, we have 1 and 15, 3 and 5. For 24, we've got a lot more of those. We've got 1 and 24. We've got 2 and 12. We've got 3 and 8. And we've got 4 and 6. And then for 27, we've got 1 and 27, 3 and 9, and that's it. So now if we're looking at all of their common factors, well, we can see they all have a 1. They also all have a 3. So that tells me that our greatest common factor, or GCF, is going to be 3. It's the greatest factor that they all have in common. As you're working on these, you really don't have to make a list every single time. If you know your factors pretty well, if you know your multiplication table fairly well, you can just look at the numbers and think, okay, what is the biggest number that goes into all 3 of these? That's a factor of all 3 of these. If it helps you to make the list, go for it, but sometimes it does get a little bit tedious. Okay, so let's add some variables in these. We're going to just take it piece by piece. We have the greatest common factor of these 3 monomials. We're going to look at just our numbers first. So let's look at 24, 18, and 12. And just kind of in your head, you can start thinking of the factors of each of those. And we're looking for the biggest one that goes into all of them. Well, if you think about it, we know that 2 goes into all of them. We know that 3 goes into all of those. We also know that 6 goes into all of those. And 6 is the biggest number that will go into all 3 of these. So our greatest common factor for our number is going to be 6. Now let's take it variable at a time. Let's look at our x's first. Okay, and careful here. We're looking for the greatest common factor. So how many x's do all of these have? Well, we can't say our greatest common factor is x to the 4th because this one right here doesn't have an x to the 4th. It doesn't have 4 x's. It only has 2. So when we're looking at our variables, we're really saying what's the smallest amount that they all contain that is common to all of them? Well, in this case, they all have at least 2, so our greatest common factor for our x's would be x squared. Let's look at our y's. We have y squared, y to the 4th, oops, that's not a y, and y to the 1st. Well, they all contain at least a y to the 1st. We can't take any more out because this one doesn't have any more. And then if we do the same thing with our z's, we've got a z here. We don't have a z here. We've got a z to the 5th here. So we can't take out a z because this one right here does not have one. It has to be common to all of them in order for us to include it in our greatest common factor. So that says our greatest common factor is going to be 6x squared y. Okay, so when we have a polynomial, in this case a trinomial, these are the three terms that we're looking at. And we're going to factor out the greatest common factor. So we're not just finding it, we're factoring out and seeing what we have left. So let me show you what that looks like. We're going to look at our numbers first. We have a 4, a 20, and a 16. Well, 4 goes into all of those. 4 is a factor of all of those. So I'm going to factor out a 4. And when I say factor out, it's going to go on the outside of my parentheses. And we're going to see what we have left once we take that out. So this piece right here is our greatest common factor. We also want to check for our variables. We have an x squared, we have an x, we have nothing. So because this one right here does not have a variable, we can't say that that's part of our greatest common factor. We cannot factor out a variable. So when we factor out a greatest common factor, it's kind of like we're dividing each piece by that. We're taking it out of each term, and we're going to see what we have left. Well, 4 divided by 4 is just 1x squared, or x squared. Negative 20x divided by 4 is minus 5x. 16 divided by 4 is positive 4. So this is factored. We took out our greatest common factor. We'll learn how to continue factoring those later, but this number out in front is what we can take out of all of them. If you want to check it, you could just multiply it back in. You could distribute it back in and just make sure we get the same thing. Okay, if we try that again here, we have 25x to the fourth minus 15x cubed plus 20x squared. So let's look at our numbers first. 25, 15, and 20. Well, they can all be divided by 5. 5 is a factor of all of them. And then let's see about our x's here. We've got an x to the fourth, x to the third, x squared. We can take out an x squared because they all contain at least an x squared. Okay, so this out here, again, that's our greatest common factor, our GCF. We're going to see what we have left when we factor that out. So it's kind of like we're dividing each piece by 5x squared. 25x to the fourth divided by 5x squared is 5x squared. Divide the numbers, subtract the exponents. For our middle one, negative 15x cubed divided by 5x squared is minus 3x. You can write 3x to the first, you can just write 3x. And then our last one, 20x squared divided by 5x squared, just gives me plus 4. We don't have any x's left because we factored them all out. So we end up with our GCF out in front, our greatest common factor, and then what we're left with inside those parentheses. Okay, a couple more times here. We've got still 3 terms. 1, 2, 3. We're just going to see what we can take out. So always start with your numbers, with your coefficients. 3, 5, and 4. The only common factor that all of those have is 1. So you can write a 1 on the outside, or you can just write the variables we're going to write either way. Now let's look at our x's. We've got x cubed, x to the fourth, and x to the first. Since this one has an x to the first, that's all we can take out. They all have to have it in order for me to factor it out. Okay, let's look at our y's. Y squared, y cubed, y to the fourth. Well, our smallest amount is y squared, so that's all we can take out because it doesn't have any more than that. And then if we look at our z's, we have z to the first, z to the fifth. We don't have any z's there, so we can't take any out since they don't all contain them. All right, so let's see what we're left with when we divide each piece. We're dividing all of it by xy squared, this term as well, this term as well. So we're not changing our numbers. It's like we're dividing them by 1. So our numbers, our coefficients are going to stay the same. We have 3. We had x cubed. We took 1 out. We end up with x squared. We had y squared. We took them both out. We don't have any y's. And we still have that z. Okay, for our middle term here, we still have the 5. We're going to have x to the third, y to the first, z to the fifth. And then for our last term here, we're going to have minus 4. Our x's cancel, and we're going to have y to the second power. So our greatest common factor was xy squared, and this is what we're left with inside when we take that out. All right, one more here. We have 21x cubed plus 14x squared plus 7x. Let's look at our coefficients first. We've got 21, 14, and 7. They're all divisible by 7, so we can take that out. Whoops, now let's look at our variables. X cubed, x squared, x to the first. So we can only take an x to the first out, or just x, since that's all that this last term has. So our greatest common factor is 7x. It's like we're dividing each piece by 7x. 21x cubed divided by 7x gives me 3x squared. 14x squared divided by 7x gives me 2x. And then 7x divided by 7x, anything divided by itself is just 1. We don't have any x's left there. So 7x was our greatest common factor. This is what we have left after we took that out. Okay, same process here, just a couple more examples. We have 12, 6, and 8. Those are the coefficients that we're looking at. We're trying to think of the greatest common factor, or the biggest number that goes into both of those. 12, or all three of those, 12, 6, and 8. Well, the greatest number that goes into all of those is going to be a 2. Let's look at our x's. X to the 5th, x to the 4th, x cubed. I'm going to take out an x cubed. My y's, y squared, y to the 4th, y to the 5th. This one has only 2 of them, so that's all we can take out. Take out a y squared. So to see what's left, it's like we're dividing all of these terms by 2 x cubed y squared. And if it's easier, if you don't want to write it 3 times, here, let me scoot this down just a little bit. You could just say, okay, I want to divide this entire thing by 2x cubed y squared. That saves you a little bit of time writing. So for my first term, I'm going to be left with 6. X to the 5th divided by x cubed is x squared. Y squared divided by y squared cancels, so just 6x squared for the first one. For our second one, we're going to have minus 3, x to the first, or just x, y squared. And for our last one here, we're going to have plus 4, x cubed divided by x cubed cancels, y to the 5th divided by y squared gives me y to the 3rd power. So we end up with our greatest common factor out here, what's left inside in there. All right, and then our last one here. So look at your coefficients first. We have 18, 27, and 9. We're trying to think of a number that goes into all of those. Well, 9 goes into all of those. So we can factor out a 9. We have a to the 4th, a cubed, a squared. We can factor out an a squared. And all of these have a b cubed, so we can factor out a b cubed. If we do that, if we divide my entire expression by 9a squared b cubed, let's see what we're left with. We're going to be left with 2a squared, and then our b's cancel. For our middle term, we've got minus 3a to the first, and then our b's cancel. For our last one, 9 divided by 9 is 1. A squared divided by a squared is 1. B cubed divided by b cubed is 1. So like this entire thing divided by itself just gives me plus 1. So greatest common factor, what we're left with. So that's kind of the introduction to factoring. That's the basis. We have to be able to take out the greatest common factor, and then later we'll learn how to continue factoring from there.